Okay, this is revision set 2. Alright? OE open-ended question. So question 11. One look at this question and straight away you should know that it's on water cycle. Alright? So they ask you what is liquid X over here. So obviously liquid X, if you take a look at it, actually originated from your seawater, the water component. So in short, it is actually a water cycle. So what actually happens is that your sun will give off heat. The heat is then absorbed by the water here. Your water will then gain heat and then evaporate. After that, it goes up, touch the cooler surface over here, loses heat, and then after that condenses into water droplets over here. Okay, so and then after that it flows towards the center and drips down. So liquid X would be pure water. Now I will only accept water or pure water. Pure water is the better answer. I will not accept purified water. I will not accept drinking water. No, all this I will not accept. So explain how liquid X was formed. This is a very classical, okay, water cycle. So water cycle question contains of two parts. Two parts would be your evaporation and condensation. So part 1. So you would say that, okay, seawater gains heat from the sun. Remember, heat source. I know some of you will probably ask, do I need to say water in the seawater? No need, it's understood. Okay, and evaporates to become water vapor. Then after that, point number 2, warmer water vapor rises, then touches the cooler surface of the plastic sheet. Point number 3, loses heat and, okay, point number 4, and condenses into water droplet. Okay, so there is no shortcut to this. It's really about practicing. So that's why I keep asking you to, when you annotate, you have to keep annotating, simply because practice makes habitual. Now, Jonathan wanted to collect the most amount of liquid X. So remember this. So how do you get more of liquid X? How is liquid X being formed? So liquid X is formed through the process of evaporation and condensation, right? So basically, you have two methods. One is either you increase the rate of condensation, or 2, you increase the rate of evaporation. In this case, the more logical and the simpler way would be to increase the rate of condensation. So how to do that? We can either replace the stone with ice cubes or put ice cubes at the top over here. So what does it do is that it lowers your temperature. It further cool down your plastic sheet, so that heat loss will be faster from from this part. Remember, water vapor rises, touches cooler surface, loses heat. So when you decrease the temperature of this plastic sheet, you are actually making the process of this part, the losing heat, faster, because there's a greater temperature difference between your water vapor and your plastic sheet. So you could say add ice on top of the plastic sheet. So this would be, okay, to increase or to decrease or to increase the rate of condensation, if you want to actually expand on that. Now it is important to note that you have to give me you have to tell me what to do. You cannot just say lower the temperature of the plastic sheet. It will not work. 0 marks. Okay, you have to tell me how. Next. Okay, this one. This question. Okay. So this question talks about your surface, exposed surface area. Okay, so they did told you already. There's this person called David. He conducted an experiment. Okay, Davy, sorry. She then folds them. Okay, this one never fold. This unfolded. This one over here fold twice. This one become half. And this one becomes a quarter because she folded it twice. Okay. Now, then she measured the mass of each cloth after 30 minutes. So whenever you deal with experimental question, you always want to ask yourself, what is the measured variable? So the measured variable would be the mass. Okay, now the mass is a proxy. So what is a proxy? A proxy means that you actually it's to stand for something because you couldn't measure something directly. So for example, okay, the mass of something left over, okay, let's just say you have a glass of water, and then after half an hour you measure the glass of water, okay, or how much is remaining. So because technically you cannot measure the rate of evaporation directly, you use a proxy. So by looking at the amount of water, you're not measuring rate of evaporation directly, but you can deduce from it. So the lesser the amount of water left, the higher the rate of evaporation. Similarly, from here, this mass is actually your measured variable. Okay, and your measured variable in this sense, okay, can actually be a proxy for or could stand for your rate of evaporation. That is what you want to find out actually. Okay? So when you look at it, okay, then what's your change variable? Remember I told you the change variable, right? The change variable, okay, I know in literal English it's like, oh, the amount of times they folded, right? The number of times it was folded. But actually, once again, this is talking about amount of exposed surface area. That is your measured variable. Annotate this. Okay? That is what it stands for. Now, then moving on. Okay, sorry. Yes, thank you. This should be change variable. Thanks for pointing it out. Okay, so then after that, they ask you to then figure out what could it be. So obviously, this should jot you back, okay, on evaporation, right? Okay, W-E-T. W stands for wind speed, E stands for exposed surface area, T stands for temperature. As all these factors increases, rate of evaporation should increase. So when you take a look at it, your D has the largest exposed surface area, so it has the highest rate of evaporation. Therefore, the amount of liquid that is left behind would be the least. So this is D. Okay? So mass means the weight. Weight of what? Actually, it's the weight of water. Okay? Now, then after that, which one should have the most amount of water left over? That will be your clause F, because it has the smallest amount of exposed surface area, which means that rate of evaporation is the slowest. Okay? So therefore, it should have the most amount of exposed surface, most amount of water left behind. That leaves E. So E, D, F. Now, what is David's aim of experiment? So the whole idea was that he wanted to find out, okay? Okay, so the aim of the experimenter would be to find out if area of exposed surface affects rate of evaporation. Alright, so the key word here would be exposed surface area and rate of evaporation. So do you realize you cannot say things like, oh, to find out if the number of times you folded the cloth will affect the time it takes to dry. Okay, or the amount of mass the cloth has at the end of the experiment. No, because those are proxies, meaning what is it that it's supposed to represent. Okay? Next, Debbie repeated the experiment with all the cloth unfolded now. Okay, then you take a look at what's the change variable. The change variable would be that the different number of fans. So this one has 3 fans, 2 fans, 1 fan. So straight away, you recall WET again, right? So you know the number of fans, okay, will obviously increase in number of amount of wind speed. So the question goes on to ask, which is the best location to place the wet cloth so they will dry the fastest? So dry fastest means highest rate of evaporation, right? Highest rate of evaporation. So ask yourself, since you already know that increasing wind speed will increase rate of evaporation, the one with the most number of the highest amount of wind speed will be the best location, which translates to the place with the most number of fans. Now the issue with this is that many of you have told me, okay, that the more, because location X has the most fans. Most fans, no use. Why? You never turn on. What is it about the fan that makes it increase the rate of evaporation? Is the wind speed. So the answer has to be, firstly tell me CER, right? Can you CER? You can also don't. So the first thing will be location X. Why? So you need to say that location X has the most number of fans, right? Compare and contrast. A lot of you tell me more. Huh? More means what? Yeah, so you need to be specific. Has the most number of fans. This results in the highest amount of wind speed, right? Which causes the highest rate of evaporation. Correct? So because highest rate evaporation then means that, okay, your water would dry the fastest. Alright? Be very careful. So many of you just tell me most number of fans. I can put 10 fans, but I don't turn on any of them. Alright, next question, very straightforward. Once again, it's on your heart rate question. Okay, I will show you that you need to memorize the previous revision paper's answer to answer this. So let's take a look. Sheldon wanted to study how 2 different types of activities, A and B, will affect his heart rate. He started each activity at the 10th minute and recorded his heart rate for the duration of the activity as shown in the graphs below. So what's the change variable? So obviously everything is the same except for your type of activity. Now, once again, don't just tell me activity. What is your quantifying term, type? Which activity A or B requires more energy? Explain your answer. So obviously, if you take a look at it, it will be activity A. Why? Because the heart rate was actually at 110, which is higher than B, that's about 90. So then you have to explain, right? Why? So once again, you would want to repeat the very common question. So 1, okay? Activity A. Then you go on to talk about the same old story. The heart pumps faster to transport more oxygen and digested food. Once again, this is the 1 point together to muscle cells. This increases rate of rate of respiration to release/produce more energy, okay, to meet the demands. Okay, sorry, let me undo this. To meet the increased energy demands of a vigorous, okay, or a strenuous activity, or what word did they use here? Or of an activity that requires more energy. Okay, we use back the same word in the question. Alright? Next, Sheldon heart rate at rest is 60 beats. Okay? Now, then after that, his teacher advised him that he should wait 10 minutes for his heartbeat rate to reach 60 beats per minute before carrying out. Okay? Explain why. So this is actually, okay, got to do with fair tests. However, it shouldn't be so straightforward. So even though if you say, oh, this is to ensure fair test, right, it's actually not detailed enough. You need to be explicit, okay, which part of it. So even if I'm giving you correct, please write this down. Okay, you need to specifically say is, this is to ensure that any increase in heart rate is solely due to the activity due to the carrying out of activity A and B. Okay, next question is on reproduction. Okay, so let's take a look at it. Now, the diagram below shows a female reproductive system named part X. So for reproduction system, mostly it's about memorizing the function and identification of the various parts. So part X over here will be your womb or your uterus. Okay, so I'm just quickly going to label everything for you. This is your ovary. This is your vagina. This is your fallopian tube. Okay, did I miss out any part? No, I don't think so. Okay, now they ask you what happens during fertilization. Be very careful. A lot of you misread this question as what happened after fertilization. If it's after fertilization, then your answer will be cell division. But when you talk about during, you have to say that the egg fuses with the sperm. Okay, or you say even higher order would be the nucleus, okay, fuses with the nucleus. The nucleus of the sperm fuses with the nucleus of the egg, or the nuclei of the egg and sperm fuses. Yeah. Okay. Next. Okay, so this is a higher order question that's thinking. Now, many of you did not get this question right because you didn't phrase your answer correctly. From your answers, I know you know why, but yet you don't get the marks because the keywords or the concept that you want to say is not articulated in it at all. So we all know that the egg will come from here, and then it will go into the fallopian tube and move towards your uterus. Your sperm will come from this way, right? And then they will meet somewhere in the fallopian tube. So a lot of you say things like, oh, the sperm cannot swim to the fallopian tube. That's not true. This is still the fallopian tube. What? The cut was made here. So technically your sperm can still swim and do here. No issue. And if your egg is here, technically your egg can still go into the fallopian tube. So what is happening is that they are not able to meet. That is the key thing. Unable to reach or meet the egg for fertilization to occur. Okay? That is the key thing. I need both. Alright, so you must say the sperm is unable to meet / reach the egg for fertilization to take place. Okay, so the first part must qualifies the second part of the answer. If you just tell me that fertilization cannot occur, right, I cannot give you the marks. Simply because there's so many reasons why it cannot be fertilized, right? Okay? But because you tell me cannot reach due to the physical defect here, or the surgery has made, that's why it cannot be fertilized, because they cannot meet. Yes, then it qualifies for the second part.